Well, first we learned what it meant for two triangles or other shapes to be congruent. It turned out that it meant if two triangles were congruent, then there were 6 things that had to be congruent. All 3 pairs of sides had to be congruent, like AB to PQ, BC to QR, and AC to PR, and all the angles. The 3 angles have to be congruent to the other 3 angles, A to P, B to Q, and C to R. So that was 6 things that had to be congruent. 3 sides and 3 angles had to be congruent. That meant the 2 triangles were congruent. But then we learned that we did not have to have all 6 pieces of information to be able to conclude that the 2 triangles were congruent. We learned that we could get away with only 3 pieces of information. If we had the right 3 pieces of information, we could assume and know that the other 3 parts were also congruent. Now let's see, what were those 3 pieces of information? It turned out that we could get away with 3 pairs of sides. If we knew that 3 sides of one triangle were congruent to 3 sides of another triangle, that was enough. Now there's a total of 6 pieces of information, and we're saying, well, if we are given these 3 pieces, we can assume that all 6 pieces of information are true. In other words, if these 3 sides are congruent to the other 3 sides, that means the 3 angles must also be congruent, because that's the other 6. Anyway, this situation was called SSS. What did SSS stand for? SSS stood for side, side, side. 3 sides congruent to 3 sides. So that was one situation. What was the other situation we found where we didn't actually need all 6 to know that the triangles were congruent? What were the other 3 pieces of information we could get away with? Here is the other one that we talked about. If we were given the right 2 sides and an angle congruent to 2 sides and an angle, that turned out to be enough information that we could assume and believe that the other 2 angles are also congruent and the other pair of sides are also congruent. But we had to be careful. It couldn't be just any 2 sides and an angle. They called it 2 sides and the included angle. Let's color this up to make it clear about this whole business about the included angle that we spoke about. See this side that's marked congruent? I'm going to color that side red. Come on. Fail. Okay, so PQ is one of my congruent sides. So here I'm going to color PQ. Notice that QS is one of my congruent sides. So I'm going to color QS. Now, the angle, when they talk about the angle that's congruent, it has to be the angle that is formed by the congruent sides. It has to be the angle that's in the V. It can't be one of these angles out here at the opening of the V. So same thing over here. Over here I've got there's a congruent side, there's a congruent side, and it had to be the angle in the middle between them. That is what is meant by the included angle. Anyway, if we had 2 sides and the included angle congruent to 2 sides and the included angle, It turned out that that was enough information to prove that the triangles were congruent. 3 pieces of information did it, not 6. We didn't need all 6. And the abbreviation for that was side, angle, side. That's way too small. Alright, the abbreviation of that was side, angle, side, SAS. And that let us know that we needed 2 sides and the angle in the middle. That's why even when we write SAS, the angle has to be in the middle between the 2 S's, just like the angle has to be in the middle between the 2 sides. So those are the things that we learned so far. Okay, so we learned we didn't need all 6 pieces of information. We could get away with either having all 3 sides, that would be enough, or we could get away with having 2 sides and the angle in the middle. Well, let's see. What other possible ways are there to write sides and angles? What else could we come up with if we played around with this? For example, we have side, side, side. What about angle, angle, angle? Well, I'm going to color that red because that's a fail. That won't color it red. Okay, that's a no. It turned out that angle, 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 having 3 angles that are the same would not guarantee that the triangles are congruent. Okay, and that only made sense because look at this triangle right here. For example, this could be 60, that's a thick pen. Let me try that again, thinner. This could be 60 degrees and 60 degrees and 60 degrees. Okay, now here's another triangle that has those same degrees. Okay, this is 60 degrees, this is 60 degrees, and this is 60 degrees. So look, we have all 3 angles congruent to all 3 angles. That would be angle, 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 if there was such a thing. But are these 2 triangles congruent? Obviously not. We have a small one and a big one. So having all the angles the same doesn't prove the triangles are congruent, obviously. So there is no angle, angle, angle theorem. Okay, what else can we do with these letters? Alright, we have we have side, side, side. We have side, angle, side. Let's see, what else can we do? What about 2 angles and a side? Angle, side, angle. What would that look like? Alright, well, angle, side, angle, that would be 2 angles and the included side. In other words, 2 angles and the side that's between them. So look at this picture. It turns out that this is another case that will be enough information to prove that 2 triangles are congruent. If we have 2 angles like this and the side between them, so I have angle A and angle C, and then it had to be the side in between. It wouldn't work if I had these 2 angles and then I had side BC. Oh no, it has to be the side in between. Just like when I make the letters angle, side, angle, the side has to be between the 2 angles. So if I have 2 angles and the side that's right in between them congruent to 2 other angles and the side that's right in between them, those three pieces of information, the angles, the sides, and the angles, once again, that will be enough information to prove that the whole triangle is congruent. Okay, so far we have side, 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 angle, side, angle, side, angle. We tried angle, 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 but that didn't work. Is there anything else we could come up with by rearranging these letters? Let's see. Well, let's see. Well, what if, I said it wouldn't work if the side was not in between them. That wouldn't be angle, side, angle. And that's true. It wouldn't be angle, side, angle, but maybe it would be another postulate that would also work. Let's take a look. Okay, well, here is what this would look like. Angle, angle, side. That would mean two angles in a row, and then the side that's not between them. That's why it's off to the side like this. So here's what that picture would look like. Here I have two angles in a row, but then I have the side that's not between them. So that's angle, angle, and then a side. Now it turns out this is enough information to prove that two triangles are congruent. So it works when the side is between the two angles, as in angle, side, angle, but it also works when the side is not between the two angles. We just call it angle, angle, side in that case. Now look, if I rearrange these letters the other way around, just to make a point here, if I wrote these letters the other way, that would make side, angle, angle. Okay, but please understand that these two things, this would not be a new postulate. These would mean exactly the same thing. Either one of these two would mean two angles and a side that's not between them. This would also mean two angles and a side that's not between them. So like the same picture I have, this, you could consider this to be side, angle, angle, if you will. But we don't use the side, angle, angle. Just by tradition, if you have two angles and the side that's not between them, we call it angle, angle, side. We don't call it side, angle, angle, because that's the same thing. Okay, what's left in terms of rearranging these letters? Is there anything that we haven't done yet? We had three sides, we had three angles. Three angles did not work. We tried two sides with the angle in the middle. We tried two angles with a side in the middle. All these things worked. Then we even tried having two angles and the side that's not in the middle between them. So maybe it would work if we had two sides and the angle that's not between them. That would look like this. Side, side, angle. So this is the one that we're going to look at right now. Luckily for me as a teacher, this one does not make a congruent statement. I can have two triangles that have a pair of sides, another pair of sides, and an angle, all congruent, but yet the triangles would not be congruent. So I'm going to color this one red because this one does not work. Okay, and I say luckily for me as a teacher because if I wrote this the other way, it would kind of make a word that was not so nice, not appropriate for school. So luckily that one's not going to be used. But I'm really mentioning that because that's going to help you remember that there is no side-side angle. There's no angle, angle, angle. Let me borrow this. There's no angle, angle, angle. And there's also no side, side angle. And it will help you remember that there's no side, side angle because it's the one that would make a bad word if we wrote it the other way. Luckily, it doesn't work anyway, so we don't have to worry about it. Now, so other than the bad word one and angle, 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 anything you can think of in terms of rearranging these letters, the side, 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 the side angle side, the angle side angle, and the angle angle side, everything works. All of these combinations of sides and angles of these three pieces of information will work to prove that two triangles are congruent. So really, if you just focus on the bad word one does not work and the AAA one does not work. Angle, angle, angle doesn't work. If you memorize these two that don't work, anything else you can think of does work. Okay? So that should help you remember. Everything works except for bad word and angle, angle, angle. Okay? So we're almost done. But there is a special case. It fits a certain kind of triangle. It's a kind of triangle that has a hypotenuse. What kind of triangle has a hypotenuse? Hopefully somebody out there said, or at least thought, a right triangle has a hypotenuse. Okay? In fact, let me pull up the professional picture. Look at these pictures that I've got right here. It turns out that triangles such as these are congruent every single time. Now let's look at the information that I've got. Once again, I have three pieces of information. But this is a very special case. What does this little box mean right here? What do these boxes mean? Go ahead. I know I'm not standing there. Answer the question. What do these boxes mean? Alright, hopefully it wasn't just crickets right then with nobody speaking. I really want you guys to participate. Don't be shy. These little boxes meant 90 degrees. Okay? That's 90 degrees. So this is a right triangle. Now, look at triangle ABC. Which part of this triangle is the hypotenuse? This is the word I'm saying. Hypotenuse. Which part of this triangle is the hypotenuse? Name the letters. Okay, hopefully I wasn't just sitting here waiting in silence for no reason. Hopefully somebody said AC. This is the hypotenuse of the right triangle. Only a 90-degree triangle, only a right triangle has a hypotenuse. And the hypotenuse is always going to be the side that's across from the 90-degree angle. It's the biggest side of the triangle, the hypotenuse. I've shown it here in red. And of course this other right triangle has its hypotenuse. There I just made it red as well. Now, if I were not paying attention to the fact that this is a right triangle, then I would say that what I have here, I have two sides, and an angle. But that angle is not in between the two sides. So if I was going to name this the same way that we name other triangles, I would be saying, well, this is a side, and an angle. But wait a minute, this is that one that we said would make a bad word. This is the one that in general does not give you congruent triangles. It turns out that this side angle situation, this only guarantees me congruent triangles if it happens to be a right triangle. It doesn't work for any other kind of triangle. If it was not a right triangle, I could not be sure that they would be congruent. But this works for right triangles. So they had to come up with a different name for it though, because if I just called it side-side angle, you would think that it worked for all triangles. So instead of calling it side-side angle, they used the fact that for a right triangle, one of those sides has a very special name that I've already mentioned. The longest side of the triangle, one of those sides is called the hypotenuse. Even the other side has a name. Alright, the long side is called the hypotenuse. The other two sides of a right triangle are called the legs of the right triangle. So this blue, that's a leg. AB is also a leg, but I'm not going to color it because it's not congruent. Alright, EF, I'm coloring that in blue. EF, that is also a leg. Okay, so here I've got a hypotenuse and a hypotenuse, and I've got a leg and a leg. So instead of calling this a side-side angle, which doesn't usually work except for in this special case, what we can do is we can call it hypotenuse leg, HL, for hypotenuse leg. And now I can turn it a happier color, because hypotenuse leg does work. Hypotenuse automatically implies that we're talking about a right triangle. So anytime you see right triangles, stop and ask yourself, do we know that the hypotenuses are congruent, and do we know that two legs are congruent? Obviously the 90-degree angles will be congruent, so that doesn't even get mentioned as an angle, because they're right triangles. Of course they have that 90-degree angle. If you have a hypotenuse and a leg congruent to a hypotenuse and a leg, that's enough information to prove that the whole triangle is congruent. Okay, now that is the whole entire list. How many things do we have? 1, 2, 3, 4, 5 things that work, and 2 things that do not work. Okay? So again, pretty much everything works. Every way that you can rearrange these letters. Side, 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 angle, side, angle, angle, side. Even hypotenuse leg, if you happen to have a right triangle, even that works to prove that two triangles are congruent. The only thing that doesn't work, the 2 things that don't work, are the one that makes a bad word if you write it the wrong way. That doesn't work. That won't necessarily make congruent triangles, nor will angle, angle, angle. So again, focus on the 2 that don't work, and you're going to find pretty much everything else you can think of does work, including the brand new hypotenuse leg that we're going to watch out for from now on. Okay, with that in mind, let's do some examples together. Now please, I ask you, do not be shy. If I ask you some questions out loud, you go ahead and answer. Even if you're at home and nobody else is in the room with you, and you feel crazy because you're talking to yourself, or if you're in the classroom and I'm not there, if you know the answer, you go ahead and say it out loud when I ask the question. Okay, maybe I should make a little list across the top of the page one more time. Let's see, these are the things that worked. Things that make triangles that actually are congruent. First we learned side, side, side. Then we had side, angle, side. Then we learned angle, side, angle would work. And then we learned that even angle, angle, side would work. And we also learned, last but not least, if we happen to have a right triangle, hypotenuse leg would work. So these are the 5 things that work. Now, what are the 2 things that won't work? I want you to really answer this out loud. What are the 2 things that won't work? Alright, hopefully you didn't actually say a bad word or anything. But one of them is the one that would make a bad word if we weren't careful. That does not work. In a second I'm going to put a big X through it. The other one that does not give you congruent triangles is angle, angle, angle. Okay? So now let me go back and put a big X through those, because this does not work and this does not work. So I have 5 things that work and 2 things that definitely do not work. Okay, now let's run through these examples and see if you guys understood what I have been trying to teach you. Okay, is it possible to prove that the triangles are congruent? If so, state the postulate you would use. Looking at problem number 1. Well, you see I have 2 pairs of angles that are congruent. What else can I mark on this picture that's automatically true, even though it's not shown? What else can I mark? Alright, I'm hoping somebody said RT. Anytime you have a shared side, go ahead and mark that, because those are automatically congruent. So looking at the 2 triangles, I have an angle, a side, and an angle that's congruent to an angle, a side, and an angle. Is that one of the ones that work? Sure it is. An angle, a side, and an angle. 2 angles and the side that's in between. So I will say yes. We could prove it by angle, side, angle. Okay, that's how this works. Look at number 2. First of all, and I really want you to answer this, what else needs to be marked on this picture that's not marked yet? Somebody probably said the angles in the middle, the angles at L. What are these angles called? What's the vocabulary word for them? Alright, I'm really hoping that somebody said vertical angles. Even if they're sideways, they're still called vertical angles. Okay, so I'm going to mark those. Vertical angles are always equal. So let's see what we've got. We have 2 angles and a side that's not between them. Alright, because otherwise that would be KL, side KL. So I have 2 angles and the non-included side, congruent to 2 angles and the non-included side. Now if there is such a thing, this would be called angle, angle, side. 2 angles and the side that's not between them. Is that one of the ones that work? Sure is, right there, angle, angle, side. So for number 2 I would say yes, because of angle, angle, side. Okay, let's look at this one, number 3. Is there anything that I can mark that's not already given? Well, not exactly. If you wanted to, we could infer that this third angle is also congruent, because the angles inside of a triangle always add up to 180. So whatever these 2 angles are, if we subtract them from 180, we're going to get some number. If these 2 angles are the same thing, subtracting them from 180 will give us the same number. So we could be very clever and go ahead and mark angle F congruent to angle G because of the whole subtracting from 180 thing. However, that doesn't really make a difference, because If anything, this would be the angle, angle, angle postulate. Is there such a postulate? No. Angle, angle, angle does not prove that two triangles are congruent. So for this one, I would simply say no. What about this one? Is there anything I can mark in this picture that has not already been marked? Hopefully somebody said MQ. Okay, that's a shared side. We can go ahead and mark that. Now, looking at these two triangles, okay, at first glance, it looks like I have an angle and two sides. Angle, side, side. And we know that angle, side, side, or side, side angle, is not one of the things that proves triangles are congruent. So does that mean that number 4 is a no? These two triangles are not actually congruent? Oh, okay. I think I heard somebody say that these triangles will be congruent because of the little boxes, 90 degrees. These are right triangles. Anytime I see a right triangle, I'm going to stop and I'm going to ask myself, do I have HL? What do H and L stand for, you guys? Answer. Hypotenuse, leg. H stands for hypotenuse, L stands for leg. So, looking back at this picture, MQ, that's the hypotenuse for both triangles. And of course, MN, that's a leg. And PQ, that's a leg. So, I have a hypotenuse, I have a leg. I have a hypotenuse, I have a leg. So, for number 4, I will say yes. These triangles are congruent by the hypotenuse leg theorem. Okay, looking at number 5. Well, once again, angle, 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 angle. That's a no. There is no angle, angle, angle theorem, so that's not going to work. Number 6. Alright, these triangles are a little bit overlapping, so we have to be careful. But look, let's do the easy part first. You see how this is a 4 and this is a 4. Okay, so those are congruent. So that's an S. Okay. Now let's see what else we have. Look at the 6s. Let me change colors on it. Okay. The 6, and there's another 6. So those are congruent. So I have two pairs of sides that are congruent. So that's SS so far. I don't see any angles, so let's see. So what about this? Okay. Well, here's the thing. Let me change colors for a second. Let me go with green now. I've got this little part. Let's look at this part that's in green right here that I just colored. Part of that is length 2. Okay, because that goes from here to here. That's 2. And then let's say this part that's FC. Let's say if I call that X. Okay, that's the part that goes from here to here. Let's call that X. The length of from A to C. Okay, let me put this up here. The length from A to C, wouldn't that just be 2 plus X? Because I got the little 2, and then I got the rest of it, the FC part. Okay? Now, compare that to the other triangle. I feel like I need a different color. I think I'll go purple on this one. Compare that to this triangle that I'm coloring in purple right now. Okay? Look at that part of this triangle. Again, we have the 2 right here. And then we have the FC part again that I could again call X. So if I wanted this purple part of the triangle, the FD part, again, couldn't I say that that is 2 plus x. It's a little 2, and then they share this part in the middle. Okay, so both the green part is a 2, and then the middle part, and then the purple is a 2, and then the same middle part, which I called x. So if you think about it, those are the same. So that is going to be a third side that is congruent. So that one took slightly more thought. I hope you followed all that. But in the end, all three sides are congruent. So I will say yes because of side, side, side. Okay. Let's look at the last problems here. Number 7, quickly. Again, the common side right here, even though it's not shown, I can go ahead and mark those congruent. Those are congruent. So, what do I have? I have two sides and an angle. That would be side, side, angle. Is that one of the theorems that I get to use? No, it is not. So, I would have to go ahead and say no. We do not know that those two triangles are congruent, even though they look congruent. We don't know it for a fact. Let's see. Looking at number 8, we got to be a little bit careful here because there's multiple triangles depending on how you look at it. STW. Please understand that triangle STW is a triangle that goes like this. STW. Okay, that's one of the two triangles that they're talking about. Now that you focus on that, you can probably see that VWT is the triangle that goes like this. There's V, there's W, and there's T. Okay, so we're talking about the red triangle and the blue triangle. Well, look, I've got an angle right there. So I definitely have an angle. What else do I have? I have an angle so far. I also have, well, look at WT. That is another case of a common side. WT is a part of the red triangle, and WT is also part of the blue triangle. So that's a shared side. So far I have an angle and I have a side. Okay, do I have any other angles or do I have any other sides that I know are congruent? Yes, okay, I mean it's a special case, but it still counts. Don't ignore the box right here. What do these little boxes mean? Yeah, you got it. These little boxes mean 90 degrees. So in the red triangle, that's 90 degrees, and in the blue triangle, this is 90 degrees. So that's another angle that they share. Now, so is this going to be angle side angle, or is it going to be angle angle side? Well, the question is, when I look at these angles, look at the 60 and the 90 here, for example. Is the side in between the two angles, or is the side off to the side? Hopefully you can see that the side is not between the two angles. I have the 60 and the 90, and then I have the side is not between them. It's not right here. So that means this is angle, angle, side. So I would say yes, these two triangles are congruent by angle, angle, side. Okay. Notice, even though it was a right triangle, that didn't mean that we were going to wind up using hypotenuse leg. So don't fall into that trap. Sometimes a right triangles, you just wind up using it like a normal triangle. Okay, we're about to run out of time. Let's see what we have here. Again, we have the shared side, so these are going to be congruent right here, HJ. That's going to be congruent. So that's it. That's all I have. I have two sides and an angle. Okay, so normally that would be side-side angle, the way it's set up. But of course that doesn't work. But it is a right triangle. Is this a hypotenuse leg situation? Is this hypotenuse leg? Yes, it is. This double side right here happens to be the hypotenuse, and of course these are the legs. So for number 9, we could say yes because of hypotenuse leg. What about number 10? I know there's a shared side, so those are equal. Okay. Now I see an angle, and I see the side that's not between them. So that's going to be yes because of angle, side. Again, try not to get confused between angle, side and angle, side, angle. If this had been angle, side, angle, then the congruent side would have been in between the two angles. But because it is not, then it's angle, side. What about number 11? Well, the part that I can mark, guess I better do triple. Vertical angles are equal, so I can include that, but that just gives me angle, angle, which does not prove triangles are congruent. So I'm going to say no for number 11. Last but not least, leaves number 12. Number 12 is small. I'm going to have to go smaller with my ink size. Vertical angles once again. Vertical angles are equal. So these two angles are equal. Okay? So what have I got? I've got two angles and I have the side in the middle, congruent to two angles and the side in the middle. So when I have two angles and the side in the middle, I will say yes because of angle, side, angle. Angle, side, angle. Two angles and the side in the middle. Okay? That's it for the lesson. Hopefully you feel confident enough to do the homework. Do not leave class without your homework. If somehow you're listening to this at home and you didn't get your homework, you better print it out off Edmodo.